HVAC Fluids 14. I'm going over Fluids 14. The reference handbook has the formula for brake horsepower as brake horsepower equals GPM delta H specific gravity over 1714 times efficiency. In the solution, you say to use the specific gravity only if using the delta in feet of head, but why wouldn't you use it in the case of PSI? So the formula from the reference handbook, this isn't quite right. I copied it below. It's actually over 3960. So it's GPM times change in head times specific gravity over 3960 times efficiency. And that's super important. That might have been a typo, and maybe the question is still a question. So we'll talk through it anyway. But that's absolutely key. And then on the same page nearby that, they give you the definition for water horsepower, and they give it as Q delta H over 3960 without the efficiency and without the specific gravity, right? So we'll talk about why that is. Hold that thought. And then they say that that also equals Q delta P over 1715. So you can swap 1714. So you can swap out the delta H for delta P and the constant changes. So let's write these down and just kind of investigate these three. If you're working through the fluid section, if you're at the beginning, maybe you haven't dealt with this yet, but if you're in the middle or at the end, you're deep in this. So this is a super important question. These formulas come up a lot. So let's talk about that brake horsepower formula first. It says Q, volume flow rate, times change in head, times specific gravity, over 3960 times the efficiency. Now this is the formula for the brake horsepower, which is separate and distinct from the water horsepower. How are they related? Well, the brake horsepower is all of the mechanical work, the power of a spinning shaft coming from the output of a motor that's driving a pump. So if you think about how much power is being actually produced by the pump, the water horsepower or the fluid power, it's only a fraction of the brake horsepower, and that fraction is the efficiency. So to say the same thing differently, the water horsepower is the efficiency times the brake horsepower. Or if you'd like to rearrange that, you can say the brake horsepower is the water horsepower over the efficiency. So the difference between the water horsepower equation and the brake horsepower equation is just the efficiency. So we can rewrite this formula exactly as it is here and just exclude the efficiency, and we'll have the water horsepower. So let's just do that. Now, notice I still included the specific gravity. And the reason that we do that is because even though this is called the water horsepower, it actually would be a better term to call this equation fluid power, so that we can keep it general and we can use it. Sometimes you'll hear it called hydraulic horsepower. That's also a good term because it's generic. As soon as we call it water horsepower, it kind of seems like we're talking about water, and we very well may be, but not necessarily. So we want to be clear. If we're talking about any other fluid that's not water, we definitely need the specific gravity to be included. If we're talking about water specifically, then the specific gravity is 1. So we're welcome to omit that, and this equation gets simpler. But you're welcome to use this equation for absolutely anything as long as you include the specific gravity. And that's exactly what we had on this slide, Q delta H over 3960, but the specific gravity was excluded because in the reference handbook, when they present this formula, they say that it's for water. But you can use it for anything if you include the specific gravity. And this next version, you can use for anything, anytime, because there is no specific gravity and it need not be added. So this is also equal to Q delta P over 1714. And it's never appropriate to include the specific gravity in this version. You don't need it for water. You don't need it for anything. You can use this equation for anything. But you have to know the delta P, the change in pressure, which is in PSI. That's the units for that term. Whereas this has units of typically feet, it's length units. So what's going on here? Well, another thing to notice here, if you've ever taken the time to divide 3960 by 1714, then you'll have noticed that there's a multiplier there of 2.31, which is our rule of thumb. We multiply by 2.31 when we want to convert PSI to feet of water. So this is feet of water to PSI. So the reason we can use either of these two equations is because the 2.31 is being baked into the constant that we're dividing by. So it's already accounted for. We can just use the height of the column of water, and the 3960 will take care of everything. Or we can change it to PSI, and we can use this equation. So what's the takeaway here? The big takeaway is that if you want to use this equation, Q delta H over 3960, and you want to exclude the specific gravity, it has to be water. So if you were to say WHP equals Q delta H over 3960, you can only use this for water. If it's not water, you have to include the specific gravity. Why? Because the height of a column of fluid that isn't water is going to exert a different pressure. If it's more dense than water, right, it's a higher density, it's going to have a higher specific gravity. Like if it's mercury, has a density that's like 13 times that of water, it takes a much smaller column to produce the same pressure. So if you're ever not sure, like if this is just confusing you, the more I talk, it's just getting worse and worse, then just convert to pressure units, because you know the height of the fluid column. Could be oil, could be something that's less dense than water, or something that's more dense than water, and you're nervous about messing this up, then you can say, well, I know the density, I know the specific gravity for that fluid. I'm just going to change it to an actual delta P so that it has pressure units of PSI. And then you can use this equation, which never requires specific gravity. It's never appropriate to put specific gravity in this equation, because now you have PSI, not feet of a column of some fluid. All right, hopefully I didn't confuse everyone that already had that down and make it worse. Another possibility is that this question was only a question because of the 714, which should have been 3960, and maybe that would have taken care of everything right away. But either way, I think we've said enough about that.
Hey Dan, this is Peter.
Yeah,
Would that include seawater or salt water also, that formula?
anything. I mean, just once you know the specific gravity, I think if you add salt to water, it becomes lower specific gravity. Is that
Yeah, that seems about right. But I mean, it wouldn't be exactly one then, right? Pure water would be one,
right?
but salt water would be less than one,
Right.
probably.
So as soon as that specific gravity is anything other than one, you have to include it here or somehow get into pressure units. You
Is
cannot use
is there a
this.
table for that, do you know? For like other liquids like salt water or ethylene glycol or
Um,
freon or
it
anything?
might not, there might be, but you can come at it a few different ways too. Like if you can find the density, that'll
Mhm.
do as well,
Okay.
right? Because that's just the definition of specific gravity is the density of that fluid over the density of water. So if you can find that, that'll do. If you can find the specific gravity directly, that'll work.
Okay.
Yeah.
I was always taught it was the W stood for working horsepower, but it's water horsepower or
I've never heard that. Maybe
uh,
it is. I learned it. No, I'm pretty because I remember reading that in the MERM quite a bit, water horsepower.
really?
But
I've
if you
never heard that term. I've always heard working horsepower.
If you find that in a text, I'd love to see it.
Okay.
I
Yeah,
definitely,
I'll
yeah.
look for it.
But I mean, either way, I think the principle is good, right?
Yes, that's correct.
Okay. That's the
Thanks.
most important thing.